Hello guys, you're welcome to Vince Tech class. And in today's tutorial, I'm going to walk you through breast cancer classification using neural network. We start by importing our libraries. First, we import NumPy as MP, we import pandas as PD, we import matplotlib as plt, we import sklearn.datasets. From sklearn.module selection, we import the train test splits, which we use for splitting our dataset into training and testing. We also import the TensorFlow as TF, and from TensorFlow we import the keras, and we also import the seed and the set seed. The essence of this set seed is to prevent your accuracy from changing each time you run the model. Next, we load the data from the sklearn, and this dataset was collected from the scikit-learn. And scikit-learn provides clean dataset for you to use when building machine learning models. And when I say clean, I mean the type of clean that is ready to be used to train a machine learning model. And also, having ready-made dataset is a huge asset because you can get straight to creating the models and not having to spend time obtaining, cleaning, and transforming the data. So it is something that data scientists spend a lot of their time on. But in this sklearn, you have a clean data set to use to train your machine learning model. Next, we print the keys. These are the key. We have the data, target, frame, target name, and so on. And now if you observe from this value, the value are in different ranges. So there is need for scaling to make them to be on the same range. This is just an information about the dataset we are using. It was created by Dr. Williams Holberg in the year 1995. We have the class distribution as 212 for malignant and 357 for benign. That is, in this project now, we are trying to predict if the cancer is malignant or benign. So when I say benign, that is, benign does not spread to the rest of the body, and malignant, it spread to the rest of the body. So you can read more on that to get more insights. Next, we create the data dictionary, which contains our features, and we also have the target variable. This is our target variable that contains the class distribution, that is, if it is benign or malignant. And we also have our features down below. These are our features. Next, we we load the data to a data frame, and we have the column, which is the feature names. That is, names of these columns, the column names. Next, we print the first 6 rows of our data frame. This is the first 6 rows of our data frame. This is the first 6 rows of our data frame. But if you leave it as a default, it will print the first 5 rows of the data set. And these are our feature names. That is mean radius, mean texture, mean parameter, mean area, and so on. That is from these feature names. We loaded the columns. Next, we add the target column to the data frame. That is the class. That is if it is benign or malignant. Now we see the shape of our data set. And from our output, we have about 569 observations and 31 attributes or features. Next, we see the data type information of our data set. This is just the data type information of our data sets. And if you can observe, all are floats, except the class, which is an integer value. Next, we check for null values. And if you can observe from the output, our data set does not contain any null values. Next, we check for the statistical information of our data set. And if you can observe, let's take example for the mean radius. The count is about 569. This is its mean value. This is its standard deviation. This is the minimum value. And the 25th percentile is less than 11.7. 50 percentile is less than 13.37. 75th percentile is less than 15.78. And the maximum value is about 28.11. This is just the statistical information about our data set. Now we see the class distribution. That is for malignant and for benign. That is for benign, it has about 357 observations. And for malignant, it has about 212 observations. That is just the class distribution of our target variable using the value count function. Next, we split the features and the targets. We drop the class from the X features and feed it into the Y class. And next, we print our X. This is our X value. And this is also our Y value. That is our target variable. We are trying to predict if it is benign or malignant. Next, we use the train test split function to split our data set into training and testing. And we have our test size to be 20%. That is 20% of our data will be used for testing, while 80% of our data will be used for training. And we have our random state to be 2. Now from sklearn.preprocessing, we import the standard scalar. And we create the instance of the scalar, the standard scalar. The essence of doing this is to put them on the same scale. Let's say you are working with a categorical variable. So it is always a good practice to perform one-hot encoding. But in this our case, we have numerical features. So we scale them to be on the same range. And after scaling them, after transforming the S string, we store it in this S string _std. We also do the same for the X test to make them to be on the same range, so as to help the machine learning model. You can read more on standard scalar and one-hot encoding to get more insights when to use one-hot encoding and when to use the standard scalar. Next, we build our model. We have our input shape to be 30. That is the features, excluding the target variable. Because if you observe from the shape of our data set, we have about from the shape of our data set, we have about 569 observations and 31 features. But we feed it with 30 features, excluding the target variable, which is our class. This is the input shape. And we create a hidden layer with ReLU activation having 15 neurons. We also create another hidden layer with ReLU activation having 25 neurons. And we create the output layer that is using Sigmund. Just similar to the logistic regression with 2 input layers. That is if it is benign or malignant. You can also read more on these activation functions to get more insights about this project. Next, we compile our model. For the optimizer, we use the Adam optimizer. For the loss, we use the sparse categorical entropy, cross entropy. And for the metrics, we use accuracy and use other metrics like F1 score, precision, specificity, MCC, and so on. Next, we feed the model to the X train, that is the standardized, the scaled features. The Y train, the validation loss split to be 10%, and the epochs to be 20%. That is how many times your model will go through the data. And after running it on 20 epochs, we have an accuracy of about 98%, showing that this model is performing well with neural networks. And we have our loss to be 0.0570. That is, this loss and this accuracy that are inversely proportional to each other. That is, as the accuracy is increasing, the loss is decreasing, and which is a good practice. So guys, that's all for today's tutorial on neural network. If you have any question, leave them in the comment section below, and don't forget to like and subscribe to my YouTube channel. Thank you.